Hi and welcome. I hope everyone is okay. Now, in this lesson, we will go on where we stayed in the last lesson. Now we have an example about PDF or probability density function. Okay, now we can start. Uh, a, a brand of laptop battery has a lifetime of X years. It's suggested that the variable X can be modeled by the following PDF. So they give us also the function is PDF and sketch the graph of fx. Okay, now we should find the these for these value on the graph point. So we should find f2 and 2 over 2 square, it means 1 over 2. And we should the graph and y-axis and x-axis, and then x-axis is x, and the function values is are here on the y-axis, and the our x value should be beginning of 2, and 2 values across to 1 over 2, and our values is like x plus x more than x greatest the 2, and then the otherwise 0. So the otherwise is 0, like this should be this point, because when the x increase, our function is decrease. Okay, because our function is like 2 over x square. When x increase, our function value should be decrease. Okay, and now show the fx has the properties required of a probability density function. A probability density function should be positive. So if you look at the graph, your function value also positive, and the second one, our function positive. So the second one, the under the area, under the graph, area, or the under the graph should be 1. So 2 from 2 the infinity, fx dx integral should be 1. So it means the integral from the 2 to infinity, 2 over x squared dx, so it should be 1. And then we have 2 negative 2 over x, 2 from 2 to infinity. So it should be negative 2 multiply 1 over infinity minus 1 over 2. And please notice that 1 over infinity should be 0. So we have minus 2 multiply minus 1 over 2 equals to 1. And it's this situation provided the 1, so our function is PDF, because for for becoming the PDF under the area should be 1. And the other one, find the probability that the battery tests for more than 3 years. So find the battery test probability of x greatest than 3. It means the integral from the 3 to infinity, fx dx. So it should be the integral from 3 to infinity 2 over x square dx, and the probability for the probability is 2 multiply minus 1 over x from 3 to infinity. So it should be 2 multiply negative 2 multiply 1 over infinity minus 1 over 3. So it should be 2 over 3, because you know 1 over 3 is 0, equals to 0. So if I put on 0 instead of the 1 over 3, 1 over infinity, I can find 2 over 3. And the other section, work out the value m such that the probability of x less than m equals to 1 over 2. Okay, now I want to solve these section here. Okay, and the probability of x less than m means by the way m should be here, so it means this area should be 1 over 2. So the integral from the 2 to m fx dx should be 1 over 2, and the integral 2 from 2 to m 2 over x squared dx should be 1 over 2, and negative 2 multiply 1 over 2 2 from 2 to infinity should be 1 over 2. So it means, excuse me, that yes, and this is not infinity, should be m. So negative 2 multiply 1 over m minus 1 over 2 should be 1 over 2. So negative 2 over m, I multiply these hours. So plus 1 should be 1 over 2, and negative 2 over m should equals to 1 over 2, and our m value since 4. So if I want to the probability value is 1 over 2, m should be O, if n should be 4. Okay, now I want to pass the other section. The other topic is finding the median and other percentiles of a continuous random variable. The total probability equals to 1. So not only is the probability of x less than m 1 over 2, but also x greatest than m 1 over 2. Please imagine that you have a probability density function. So our probability density function, for example, let be here like this. For example, this point should be A, this point should be, for example, B. The under the area 1, if you want to the median or 50 percentiles, so this value m should be 1 over 2 and 1 over 2, and the median value is here, and the probability of this area 1 over 2. So the probability of the other part should be 1 over 2. So we say that this point, this value is the median. But if your curve is for example the beginning of the infinity and to infinity, so this probability function m, this area should be 1 over 2, and this area should be 1 over 2, and then we can say m value is median. Okay, now the value m must therefore be the median, the value of x where the probability is exactly half. The median m of a continuous random variable is that value for which x less than m, the integral from the negative infinity to m should be 1 over 2. For if you want to find the median value, you should compute this integral, and equation should be equation 1 over 2. Another way to express the median is to refer to it as the 50th percentile, and we can find other percentiles. We can find the other percentiles of continuous random variables using a similar method to that given the key point, with the fraction 1 over 2 replaced by the relevant percentage. For example, if you want to find 30th percentile, you should compute the 30% percentage, so or 0.3. For example, if you want to 20th percentile, so you should find the integral from negative infinity to r or etc. For example, y, it doesn't matter. Fx dx should be 20% or 0.2. Okay, I think when we worked the example, you can understand easily in this situation. And then for any given time, I arrive at a bus stop. The arrival time of a bus can be modeled by the continuous random variable x, whose PDF fx given by this situation. Find the median and interquartile range IQR of the arrival time the bus. Okay, now we have a PDF or probability density function, and we want to find the median, and I want to draw the graph graph for understanding easily. So our graph should begin of the zero and should finish 6, and f0 should be 0, and f6 should be 1 over 2, and this situation is 1 over 2, and our graph should be increase from 0 to 6, and I want to find the median, and the median might be here, and either this area equals to 1 over 2 and this area 1 over 2. So this point is median. This area should be 1 over 2. This area should be 1 over 2. So you can use this integral from 0 to m fx dx and should be 1 over 2, and maybe you can if you want to use the other way, and you can use easily the other integral. For example, from m to 6 fx dx and 1 over 2. It is not different. It is the same. It is the same result for finding the m value. Okay. Now I want to use the first one, and the integral from 0 m fx dx x square over 72 multiply dx and 1 over 72 like x cube over 3 0 to m, and should be 1 over 2. Okay, now 1 over 216 and m cube minus 0 should be 1 over 2. So m cube should be 108, and m should be the cube root of 180. These approximately this situation approximately 4.76 m 4.76. Okay, and now the other section we want to find interquartile range. Please remember that okay, now for the other answers I want to open the new page. Okay, and then I want to copy paste the question. Okay, now the first one, please remember that Q1 means a lower interquartile. It means 25th percentile, and Q3 is upper quartile, and it means 75th percentile. 75th percentile. So you want to find 25th percentile. Please remember that your curve like here, and these 6 should be 1 over 2, and these points, for example, it means Q1. These points under the area should be 25th percentile. So this point is 0, and you should the integral from 0 to q1 fx dx x square over 72 dx should be 25th percentile. And please remember that the PDF function under the area should be equals to 1. So these area should be 1 over 4, and the probability of these section 1 over 4, and then 1 over 216 x cube 0 to q1 should be 1 over 4, and this situation q1 cube minus 0 cube should be 54, and q1 the cube root of 54, and the approximately value is 3.78 q1 3.78. Okay, now it state there, and we will use the next and we should find the q3. Q3 might be on here, and these area should be 75th percentile. These area should be 75th percentile. Or the other way, maybe you can think the other way. These area from Q3 to 6 should be 1 over 4. Or maybe you can use these area should be 3 over 4. You can use this section or this section. It doesn't matter. It isn't different. But I want to use the integral from 0 to q3 fx dx should be 3 over 4, and 1 over 216 x cube from 0 to q3 should be 3 over 4, and q3 cube minus 0 cube should be 162, and q3 the cube root of 162, and approximately that 5.45. Okay, and then the interquartile range should be interquartile range, Q3 minus Q1 and 5.45 minus 3.78 and our interquartile range equals to 1 over 67. Okay. Okay, now in this lesson we learned the median for PDF and some percentile, and the other lesson we will go on from here. For now, have a good lesson and have a good day.